The limiting reagent will determine the amount of product formed in a chemical reaction. Hi, this is Mr. B. In this video, I'll explain how to determine the limiting reagent in any chemical reaction. Consider the reaction where manganese 4 oxide reacts with hydrochloric acid to produce manganese 2 chloride, chlorine gas, and water. The first step in determining the limiting reagent in any chemical reaction is to begin with a balanced equation. At this point, let's balance this chemical equation where 1 manganese is located on the reactant side and 1 manganese is located on the product side. 2 oxygens are on the reactant side and 1 oxygen is on the product side. So let's begin by placing a 2 in front of water. This gives 4 hydrogens on the product side, but only 1 hydrogen on the reactant side. So let's balance the hydrogens by placing a 4. On each side of the chemical equation, there are 4 chlorines. So this equation is now balanced. The next step is to write the molar ratio. The molar ratio in this equation will be 1 to 4 to 1 to 1 to 2. When determining the limiting reagent in any chemical reaction, we are only concerned with the reactant side of the equation. So in this particular reaction, the ratio that we are concerned about will be the 1 to 4 ratio between manganese 4 oxide and hydrochloric acid. According to the balanced equation, for every 1 mole of manganese 4 oxide consumed, 4 moles of hydrochloric acid must also be consumed. If for some reason the amounts of each reactant does not match this ratio, then one of the reactants will be the limiting reagent. Suppose the initial amount of manganese 4 oxide was 0.86 mole, and the initial amount of hydrochloric acid was 48.2 grams. Do you have the proper information to determine the limiting reagent? The answer is no, because when determining the limiting reagent, we must convert mass to moles, particles to moles, or volume of a gas to moles. In this case, we're given 48.2 grams of HCl. To determine the moles of HCl, divide 48.2 by 36 grams per mole, which is the molar mass of HCl. 48.2 divided by 36 is equal to 1.3. So in this case, we're given 1.3 mole of the HCl. At this point, the limiting reagent may be determined. To do so, consider the molar ratio, where the ratio between manganese 4 oxide and hydrochloric acid is 1 to 4. If we're given 0.86 mole of manganese 4 oxide, then 4 times this amount of hydrochloric acid is required to consume the 0.86 mole. 0.86 times 4 is equal to 3.4 mole. 3.4 moles of the HCl are required, but from the previous calculation, where we're given 48.2 grams of HCl, we know that there are only 1.3 moles of the compound available. In this case, the hydrochloric acid will represent the limiting reagent. Once again, given 0.86 mole of the manganese 4 oxide, 3.4 moles of the hydrochloric acid are required to consume it. However, in the information, we're only given 48.2 grams of the hydrochloric acid, which represents 1.3 mole. So clearly, not enough HCl is available. Now we know that the excess reagent will be the manganese 4 oxide, since there is not enough hydrochloric acid on hand to completely consume it. So manganese 4 oxide represents the excess, and of course the 1.3 mole of HCl will represent the limiting reagent. The amount of excess reagent remaining may be determined as follows, where it is known that 1.3 mole of the limiting reagent is on hand. To determine the amount of excess reagent required to completely consume the 1.3 mole, simply multiply 1.3 times a fraction, 1 over 4. This will equal 0.33 mole. This means that in order to consume the 1.3 mole of HCl, 0.33 mole of the manganese 4 oxide is required. Since only 0.33 are actually required and 0.86 mole is on hand, subtract from 0.86 0.33. And this will equal 0.53 mole. So the amount of manganese 4 oxide left over or remaining or in excess will be 0.53 mole. Now that the limiting reagent has been identified, it is possible to determine the amount of each product formed. Suppose we wish to determine the number of moles of manganese 2 chloride formed. The amount formed will depend on the amount of limiting reagent consumed. It is known that 1.3 mole of HCl was consumed. To determine the amount of manganese 2 chloride formed, multiply the amount of the limiting reagent, which is 1.3 mole, times a fraction created from the molar ratio, where the 1 represents the numerator and the 4 represents the denominator, which will equal 1/4. So 1/4 of 1.3 is equal to 0.33 mole of manganese 2 chloride. Suppose we wish to determine the number of liters of chlorine gas formed at STP. To do so, divide 1 by 4 and multiply times the amount of limiting reagent. This will equal 1/4 of 1.3. It is known that at STP, the volume of any gas will be 2.4. So to determine the number of liters of chlorine gas produced at STP, multiply 1/4 times 1.3 times 2.4, and the answer will be 7.4 liters of chlorine gas. To determine the number of molecules of water produced, divide 2 by 4 and then multiply the fraction by the amount of limiting reagent. 2 divided by 4 is equal to 1/2. So 1/2 times 1.3 times Avogadro's number is equal to 3.9 times 10 to the 23 molecules of water. Once the limiting reagent is known, then the amount of any product may be determined by using normal stoichiometric calculation.